Good morning, students. I hope all of you are fine today. So let's continue with the chapter which we are doing in the online classes, that is magnetic effects of electric current. Students, in our last class, we have discussed about the Fleming's right hand thumb rule, and we have also discussed about the process in which we have seen that how magnetic effects possess in a coiled conductor when we take a metallic rod, and in that metallic rod, if the current flows from A to B and from B to A, then in both the directions how current flows and how force generated by the magnet on the metal rod. Okay, students. Now our next topic is electric motor, students. Now this is the most important topic for the board exams as well, students. So see the picture very carefully, because while explaining this you need to draw the diagram in the exam as well. Okay, so what is electric motor, students? Electric motor is a kind of device which converts the electrical energy into the mechanical energy. Okay, so in which principle the electric motor works? The principle of the electric motor is based on the fact that a current carrying conductor, it produces a magnetic field around it. Okay, so a current carrying conductor is placed perpendicular to the magnetic field which experiences a force. Now we will discuss about the construction of the electric motor. The first part is called the armature coil. You can see in the picture, it consists of a single loop of an insulated copper wire which is placed in the form of a rectangular shape. You can see in the picture. Next is strong field magnet. Armature coil has been placed between two pole pieces of a strong magnet which provides strong magnetic field. Next is split ring type commutator, students. It consists of two halves of a metallic ring. The two ends of armature coil, okay, they are connected to these halves of rings. Now commutators reverses the direction of the current which is flowing in the armature coil. Now the next part is the brushes, students. There are two carbon brushes which presses against the commutator. Now these brushes act as contact between commutator and terminal battery. And last, battery, it is connected across the carbon brushes. You can see in the picture again. It supplies current to the armature coil. Now students, we will discuss the working of electric motor. Just look into the diagram carefully. Okay. Now see, in the side, if you see the AB of a rectangular coil, that is ABCD, the direction of current is flowing from A to B. And in the side CD of the coil, the direction of the current is from C to D. Now students, the direction of the magnetic field is from north pole of the magnet to its south pole, as we know that. Now, by applying the Fleming's left hand rule to the sides AB and CD of the coil, we can see the force on side AB of the coil, it will push in the downward direction, whereas the force on the side CD of the coil will push in the upward direction. So due to this, the side AB of the coil is pushed down and side CD of the coil is pushed up. So this makes the coil ABCD rotates in the anti-clockwise direction. Okay, students. Now, while rotating, when the coil reach the vertical position, okay, while rotating the coil reach the vertical position, then the brushes will touch the gap between the two commutator rings, you can see, and current of the coil will get cut off. Now though the current to the coil gets cut off when it is in the exact vertical position, that means while rotating, when the coil reaches the vertical position, then at that point of time the current gets cut off. Now the coil does not stop rotating, students, because it has already gained some momentum, that is, it is already in motion, due to which it goes beyond the vertical position. Now after half rotation, when the coil goes beyond the vertical position, the side CD of the coil comes on the left side, whereas side AB of the coil comes to the right side. and the two commutator half rings automatically they change contact from one brush to the another. Now after half rotation of the coil, the commutator half ring, that is the R2, you can see it makes contact with the brush B1, whereas the commutator half ring, that is the R1, it makes contact with the brush B2. So this reverses the direction of current in the coil. Now the reversal of direction of current, it reverses the direction of force which is acting on the side AB as well as on the side CD of the coil. Now students, the side CD of the coil is now on the left side with a downward force acting on it, whereas the side AB is on the right side with an upward force acting on it. So due to this, the side CD of the coil is pushed down and the side AB of the coil is pushed up. So this makes the coil rotate anti-clockwise by another half rotation. So by reversing, the current in the coil is repeated after every half rotation, due to which the coil, that is the insulated coil, it continues to rotate as long as the current gets passed from the battery. Okay, and as a result, the electric motor generates the electricity which is very much required for running all the appliances, for example fans, geysers, and many more appliances that we use in our household purposes, as well as that we use in factories or in industries or in school, hospitals, etc. Okay students, so in this way electric motor works. So students, in the examination part, the questions may ask that you have to write the working of the electric motor, or else you have to describe you have to define the electric motor as well as in which principle electric motor works. Now if they ask the working of the electric motor or the construction of the electric motor, in both these cases you have to draw the diagram. But in case if they have asked only the definition and the principle of the electric motor, then you will write only the answer, you don't have to show the diagram. Okay, so students, just go through the diagram, go through all the process and practice the electric motor diagram accordingly. Okay, so that's all for today students. Thank you.